The manuscript that shouldn't exist. The notebook didn't belong in that basement room. It was misfiled under thermodynamics, wedged between a broken ring binder and a stack of mimeographed lecture notes. Acid brown paper, thread binding. The front leaf carried a neat, slanted hand. On harmonic engines with notes on planetary resonance. No author, no date, but the paper watermark in ink chemistry would later peg it to the late 19th century. A graduate student named Mara pulled it because the spine looked wrong. She thought it might be an old lab ledger, good for archival credits, nothing more. 2 pages in, the handwriting turned from formal prose to dense mathematics. Integer ratios stacked in lattices, prime gaps marked in red pencil, spherical harmonics sketched like weather maps. In the margins, nodes, energy minima, engine frame, and underlined twice, gas giants. The math shouldn't have existed in that form. Integer resonance lattices, the idea that stable energy patterns emerge at whole number ratios across spherical modes, are modern tools in seismology and plasma acoustics. Nested primes guiding sequence activation? That's cutting-edge coding theory. Yet the notebook treated both like a craft. Lay the lattice, count the primes, tune the shell. It proposed that within a layered fluid sphere, discrete harmony windows would concentrate energy into predictable nodes. Not theoretical elegance, engineering notes. Mara brought it to her advisor, expecting a polite nod. Instead, he closed the office blinds and read without speaking. The equations outlined a scaffold where spherical harmonics, the standing wave patterns that fit on a sphere, interlocked at integer ratios so clean the error terms canceled like teeth in a gear. The red pencil primes weren't numerology. They indexed which harmonic families could activate without beating each other into chaos. Then came a table labeled Jupiter, with radii expressed as fractions of an assumed planetary radius, and an angle set that matched the latitudes of major jet streams, decades before spacecraft ever mapped them. Why it matters is simple. If you can predict where energy prefers to collect in a turbulent sphere, you can shape the turbulence. The notebook implied planetary design, harmonic engines embedded in gas layers, using resonance to route energy the way pipes route water. The notes suggested control of storms and magnetic fields by exciting specific modes at prime-separated times, avoiding destructive interference and distributing energy efficiently. It was a blueprint, or it was a hoax so good it anticipated discoveries no one had made. Mara tested one claim the notebook called obvious. She overlaid the listed node radii on publicly available Jupiter density models. The rough matches were unsettling. Then she converted the prime step schedule, 2, 3, 5, 7, 11, into phase windows and checked old ground-based radio logs for bursts near those intervals when Jupiter's rotation put certain latitudes in view. Too many hits to dismiss as chance. Not perfect matches, but clustered. That's when the human cost began. Her advisor told her to slow down. "You don't publish this," he said, tapping the word engine as if it could bite. He offered safe projects, thermal convection models, feature tracking. She ignored him and drafted an abstract for a small conference, carefully avoiding the word engine, calling it resonant energy localization. 2 days later, her submission portal returned an error, withdrawn by author. She hadn't withdrawn it. Meanwhile, the notebook became a riddle. Some pages referenced Galileo, which at first glance meant the person. But the phrasing, Galileo confirms the high order L equals 10 anomalies, suggested a dataset, not a Renaissance telescope. The modern Galileo spacecraft flew in the 1990s. The notebook predated it by a century, unless the notebook had been updated later by another hand. A different ink tone appeared in the margins on a few pages, the neat slanted hand interrupted by blockier annotations. Compare with GLLPWS, Juno SSW to verify. Someone had revisited the manuscript after the probes returned. So what was it? A hoax retrofitted with modern acronyms? A palimpsest where a living researcher used an antique notebook as cover? Or a decrypted blueprint from somewhere else, passed hand to hand and annotated across generations? Mara's curiosity pulled her deeper. The integer lattice wasn't a mere pattern, it was instruction. Start with the lowest spherical modes, the big, slow planet-sized oscillations. Fit them at ratios of simple integers like 2 to 3 to 5 to create a scaffold. Use primes to gate which layers receive energy at which times, so that no adjacent layer reinforces a destructive beat. The payoff, stable, long-lived vortices at known latitudes, synchronized jet streams, and an amplified magnetic dynamo without catastrophic turbulence spikes. Her mentor, trying again, walked her through the risks. Extraordinary claims, career-ending ridicule, the black hole of fringe forums. "You're smart," he said. "Don't set your life on fire." He wasn't wrong. But while he worried about reputations, Mara worried about consistency. The numbers in the notebook weren't vague. They predicted energy nodes at specific fractions of the radius and preferred longitudes tied to rotation harmonics. She pulled gravity field coefficients from Juno's public releases, J2, J4, J6, and saw minor anomalies near values the manuscript emphasized. Not proof, but a drumbeat. Then came the email. It looked routine, a request to consult on signal processing for planetary radio data. No signatures, just an institutional address and a dataset link. When she clicked, it requested two-factor authentication for a system she didn't have access to. 10 minutes later, her advisor called her into the hall. "Who did you tell?" he asked. He'd received the same message, then a follow-up. "Please disregard." She printed 3 chapters of the notebook and locked them in a campus safe. The rest she scanned to an air-gapped drive. The next morning, the basement room's keycard reader was taped over with a new notice. Collection temporarily closed for inventory. Inside, the shelf where she'd found the notebook was empty. While the ink was old, the numbers matched something modern. And somewhere, out past the campus lights, Jupiter turned, its storms circling on rails she could now describe. The signal in Jupiter's shadow. The first time the burst hit, Mara wasn't even in the control room. She was trying to coax a coffee out of a machine that ate dollar bills. In the lab, a narrowband receiver watched Jupiter's limb while the planet slid behind Earth's ionosphere sweet spot. The lost math gave a window, Prime stepping the clock, so they pointed a modest dish and let the recorder run. At 2:17, 3 knife-thin spikes rose exactly where the notebook said they would, then fell away like a hand lifted from piano strings. They didn't celebrate. They doubted the instrument. The lab had seen spurious spikes before, satellite bleed, terrestrial interference, even a microwave door that didn't seal. Mara and 2 postdocs reran the chain. The FFT pipeline, the notch filters, the local RFI map. Nothing obvious. The event straddled a predicted harmonic node window, a phase aligned with a prime-structured schedule, timed to Jupiter's rotation, so a latitude band the notebook emphasized grazed the line of sight. The spectrum looked clean. The metadata looked boring. That was the unsettling part. To keep their heads, they cross-checked public spacecraft data. Galileo's plasma wave subsystem recorded intermittent, structured radioactivity in the decametric range, often tied to Io's position, but tucked in those archives were odd sequences that didn't fit Io-driven modulation. Juno's waves instrument logged auroral hiss and bursty emissions with substructure that sometimes repeated. Mara pulled a slice of Galileo near one of the notebook's prime intervals and overlaid it with Juno's closest counterpart years later. The envelopes matched a little too well for comfort, peaks separated by intervals that mapped to the same prime steps the notebook indexed in red pencil. Skeptics had a straightforward case. Jupiter is loud. Plasma instabilities and cyclotron masers make radio noise with patterns that can mimic intention, and observational cherry-picking turns randomness into rhythm. If you watch long enough, any interval will look special. Good arguments, and nobody on Mara's team wanted to become a cautionary tale. But the lab anomaly wouldn't fit the usual boxes. The instrument auto-flagged non-natural periodicity, only when 3 independent criteria stacked. Timing within a narrow tolerance, spectral coherence across adjacent bins, and a phase consistency that survived time window shifts. It had never fired all 3 on a Jupiter pass. They scheduled a midnight recalibration, the kind where you strip the system to bone. The dish pointed at empty sky. They injected test tones at known offsets, then pulled the clock from GPS, and ran an oven-controlled crystal oscillator to eliminate timing contamination. No spikes. They swung the dish across a geostationary belt to pick up known RFI carriers. The detection algorithm behaved. They waited. At 2:11, they returned to Jupiter and held the gain low to avoid front-end compression. The prime window approached. In Mara's notebook, hers not the antique, a penciled line traced the seconds. At 2:17, the spectrum trembled, then the triplet stood up again, slightly shifted, same spacing. She didn't exhale until it was gone. Meanwhile, something else was happening across town. A friend at a different university had agreed to run a parallel observation as a sanity check. No shared clocks, no shared software. Their system wasn't as sensitive, but the time stamps would tell a story. The next morning, an email with no subject arrived. We saw it too. One peak only. Same second. Their data had lower resolution, and the other two spikes were buried in noise. But the coincidence tightened the loop. What nobody knew at the time was that Galileo's team had once dismissed a sequence like this as ground system artifact. A footnote in a technical memo mentioned a repeating triad near the limb during a pass when Io's influence should have been minimal. It was flagged and filed. Mara tracked down the memo through an old FTP mirror because the main archive didn't index that page. The triad spacing mapped, again, to the prime intervals in the manuscript. If periodicity is intentional, you aren't listening to weather, you're hearing a clock. The stakes snapped into focus. A clock implies state, state implies a system, and a system implies behavior that could wake, idle, and respond. That's a different kind of risk than bad optics at a conference. You don't accidentally ring a bell like that. So they tried to break the case. They mapped the bursts against known decametric modulation by Io and found the timing sat off the classic IOA and IOB sources. They compared to Earth-based RFI catalogs and saw no carriers near the triplet bins during those seconds. They folded days of Jovian rotation to see if the pattern repeated at a simple rotation harmonic. It didn't. It appeared only in the prime-spaced windows the notebook predicted. That cut both ways. It strengthened the manuscript's claim, but it also raised the danger of confirmation bias. A quiet voice in the room kept repeating, "Prove the negative." Mara scheduled a blind test. She randomized timestamps from Blank Sky and from Jupiter, shuffled the labels, and asked a colleague who didn't know the project to run the detector. The algorithm flagged only the true windows near Jupiter, not the decoys. Then they removed the prime window constraint entirely and scanned a month of data. No triplets. The lab anomaly was stubborn. During one long night, as clouds rolled over the dish and wind pressed the dome seams, the team debated the skeptic's strongest line. Non-natural periodicity is a loaded phrase. Nature loves patterns, but the lab's own metric didn't declare intelligence. It declared a pattern that didn't match their current catalogs of natural drivers. That was enough to justify a deeper look and not enough to hang a career on. Still, the clock metaphor stuck. It kept time across instruments and years. It ticked in a way noise didn't. By the third detection, the coffee machine worked. A small mercy. The triplets had slight phase drifts, predictable if a rotating shell was involved. The drifts matched the manuscript's note about precession of active shells, scribbled in a different ink. The pattern wasn't random, it was a clock. And if there was a clock, something somewhere cared about the hour. Harmonic Architecture 101. To understand the clock, we need the architecture that could keep time inside a storm. Start with resonance scaffolding. In any sphere, waves can stand in patterns called spherical harmonics. Think of them as ripples that wrap a globe, each with an index, L for the number of nodal bands, M for how they twist around longitude. Most combinations interfere and die. But when you stack a few at simple integer ratios, 2 to 3, 3 to 5, their energy reinforces and locks, creating long-lived structures. The manuscript's integer lattice took that basic physics and made it prescriptive. It mapped a grid of allowed modes where L and M pairs sat on integer rails that minimized crosstalk. Then it layered time. Those red primes weren't decoration. They sequenced when each mode could accept energy. A prime step schedule, 2, 3, 5, 7, 11, staggered injections so no two adjacent shells beat against each other. You get clean buildup instead of turbulence. Spherical harmonics meeting prime-based sequencing sounds esoteric, but it's an engineer's trick. Integer ratios reduce error accumulation. Primes prevent synchronized collisions. The notebook argued that a gas giant's layered convection could be coaxed into quasi-stable lanes if you excite the right modes in the right order. That's harmonic control, not brute force. You don't fight the storm, you whisper to it at frequencies it can't ignore. Now remember what Juno and ground-based imaging teach. Jupiter's atmosphere is banded, east-west jets, stacked like conveyor belts. In the lattice, those bands coincide with latitudinal nodes where certain L modes concentrate shear. Antinodes, where the standing waves bulge with energy, line up with the long-lived vortices. The Great Red Spot sits near one such antinode latitude. The manuscript's table, angles and radii penciled with care, predicted not just bands but preferred longitudes, where intersecting modes create cradles for vortices to persist. Visualize it, nested shells of gas, each carrying a dominant mode. At certain depths, metallic hydrogen forms a conductive sea. Above it, molecular hydrogen behaves like a compressible fluid. The lattice runs through both. Energy routing happens along the nodes like tracks, shunting momentum laterally before it can blow vertically into chaos. Antinodes act like capacitors, soaking energy and releasing it on schedule. That schedule is the prime sequence, a metronome that opens and closes windows to shuffle power without collision. Mara's mentor called it beautiful and dangerous. In a quiet hallway he said, "You don't publish this." He'd seen careers shredded by symmetry that looked too neat. He warned that nature rarely respects our clean grids. But even he couldn't ignore how the lattice explained otherwise stubborn features. Jets that refuse to diffusive away, vortices that last centuries, auroral power that varies in steps. Take the magnetic field. Jupiter's dynamo lives in that deep metallic layer, where charged flows cut magnetic lines and generate the magnetosphere. If the lattice modulates flows there by gating torsional oscillations, those slow twist waves that spin bands faster and slower, you get controlled variations in field strength. The notebook treated torsional waves as the machine's belts, moving angular momentum between shells on a prime cadence. Storms above ride those belts like timing cams on an engine. Engine language isn't just metaphor in the manuscript. It spoke of valving layers, couplers, and quench intervals. In plain physics, those could be stratification boundaries where density jumps reflect waves, shear zones where momentum transfers, and radiative layers where heat can dump. The prime windows would be the quench intervals, moments when the system breathes, letting pressure equalize without feeding instability. Meanwhile, something else clicks. Spherical harmonics don't care about liquids versus plasmas. They care about geometry and boundary conditions. That's why the same math shows up in starquakes, Earth's free oscillations after big earthquakes, and even room acoustics. The notebook exploited that universality. It unified acoustic mechanical control across phases of matter by choosing integer families that survive damping. That's why ancient math would aim this way. If you didn't have transistors, you'd use resonance and ratio. Stone circles that pick up whispering gallery modes, temple chambers that focus chant frequencies. It's the same instinct, scaled to a planet. Let's ground it in one clean scene. Mara took a standard spherical harmonic expansion used in weather models, YLM functions, and restricted the basis to integers the manuscript allowed. When she ran a toy simulation, jets aligned, and rogue vortices damped quicker than in the full basis. When she loosened the integers, chaos returned. Not proof, but a sign. Constraint creates order. The impact of accepting this architecture is heavy. If a resonance scaffold exists, storms can be modulated like turbines in a dam. You can bleed momentum from one latitude to another, steer heat from deep layers toward selected outlets, and throttle the magnetic field without frying the system. Maintenance signatures would look like sudden calm where chaos should reign, stepwise shifts in jet speed, and radio emissions that arrive on a timetable. We've brushed against all three. So if there's a clock, there must be a machine. A machine doesn't have to be gears and pistons. It can be geometry and timing. The manuscript drew the geometry. The prime sequence kept the time. Jupiter provided the mass and the medium. And out at 2:17 universal time coordinated, something kept the beat.